This video is on angles in circles. A central angle of a circle is an angle whose vertex is the center of the circle and whose sides are radii of the circle. So for example, for circle B here, angle ABC is a central angle because B is the center of the circle and that is the vertex of that angle. The sum of the central angles of a circle is 360 degrees. So here we have three central angles, angle 1, angle 2, and angle 3, and the measures of those three angles added together is equal to 360 degrees. The measure of an arc intercepted by a central angle is equal to the measure of the central angle. So for example, since the measure of angle PRQ is 115 degrees, arc PQ, the measure of arc PQ is also 115. So when we use this word, maybe you haven't seen this word intercepted before. So here we have the angle PRQ, and if you could imagine that perhaps you're slicing a pizza that way, we say that the arc that it intercepts, it would be this pizza crust right here, this arc PQ. So the measure of a central angle is the same as the measure of the arc that it intercepts. An inscribed angle of a circle is an angle whose vertex is on the circle and whose sides are chords. So an inscribed angle is literally written inside the circle. Notice that its vertex is not the center, as with a central angle. Its vertex is actually a point that is on the circle. And so here we have angle QRS, and you'll notice that QR is a chord and RS is a chord, and our vertex R is on the circle itself. The measure of an arc intercepted by an inscribed angle is twice the measure of the angle. So here we have a circle with our inscribed angle is angle 1, and you'll notice its vertex, which is unnamed, is on the circle here. So the measure of angle 1, the measure of this angle right here, is going to be 1/2 of the measure of arc AB. Remember that with a central angle, that is an angle whose vertex is the center, the measure of the angle and the arc are the same. Here, the measure of the angle, the inscribed angle, is 1/2 of the measure of the arc. Or another way to think of that, the measure of the arc, measure of arc AB, is going to be twice as big as the measure of the inscribed angle. If an inscribed angle intercepts a semicircle, that is a half of a circle, then it is a right angle. So here we have angle FGH, and you can see that that cuts off or intercepts this arc FJH right here. Because FH is a diameter, arc FJH is a semicircle whose measure is 180 degrees. Therefore, we know that the measure of angle FGH is going to be 90 because the angle is going to be half of the arc. You'll also notice that that's created a really nice little right triangle in there with a right angle here, and the hypotenuse is the diameter of the circle. If two inscribed angles intercept the same arc, then the two angles are congruent. So here in this circle we have a whole lot of chords going on here, but you can see angle B, angle ABD, okay, intercepts arc AD, and angle C, ACD, also intercepts arc AD. Because they both intercept the same arc, we know that those two angles are going to be congruent to each other. So angle B is congruent to angle C. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So here we have quadrilateral KLMN, and it's inscribed in circle A. That means that all four of its vertices are actually on the circle. And this theorem says that opposite angles are supplementary. So the measure of angle L plus the measure of angle N, since those are opposite each other, are going to equal 180. And the measure of angle K plus the measure of angle M also equals 180. Why is this? Well, if you take a look at angle L, notice that angle L intercepts this arc that goes from K through N to M, and angle N intercepts the arc that starts at K, goes through L, and over to M. Well, if you take those two arcs, they make up a complete circle. So since the degrees in the circle are 360, those angles are going to add up to 180. And our last theorem here says that if two chords are congruent, then the arcs that they intercept are also congruent. So if we're given that segment FG, which is a chord, is congruent to segment JH, which is also a chord, if those two chords are congruent, then the arcs that they intercept are congruent, so arc FG is congruent to arc JH. So in this video, we took a look at angles of circles and a lot of different segments that are in circles, including arcs and chords, and a whole lot of different theorems. Make sure that you have drawn pictures of these and included these not only in your math journal, but also put them into the glossary in the back of your notebook.